Okay, we're going to do this problem. Let's construct triangle ABC at s equals 2 inches, 2 inches, and 2 inches. Then we construct an angle bisector for ABD bisecting angle ABC. All right, so for the equilateral triangle, and we know it's equilateral because it says 2 inches, 2 inches, 2 inches. All right, there you go. Those are the arcs. The equilateral triangle. Of course, you just go to the spot where the two arcs intersect, and we have our equilateral triangle, and that is point A. All right, angle bisector BD bisecting angle ABC. Well, BD has to come from B, so I've got to use B to begin with. So I do an arc there, then I do intersecting arcs based at the location of the original intersections. And I create my ray there. Point D will be the spot where the ray intersects the triangles. That's D. Okay, now let's think about this. This is 2 inches, so this is also 2 inches. And this is 2 inches, meaning that this is 1 inch and 1 inch, because this has bisected it. This and this and this are all 60-degree angles. So this is bisected, then this has to be 30, and this has to be 30. And if this is 30 and this is 60, that makes 90, so this also has to be 90 degrees. So if we need to know how long AB is, well, that's 2 inches. If we need to know how long BD is, well, look at this. This is side A, this is side C, so this would be side B. So it would be 1 times the square root of 3, so it's just the square root of 3 inches. That's how long BD is. And then AD will be 1 inch. Measure of angle BAD would be 60 degrees. Measure of angle ABD would be 30 degrees. Measure of angle ADB would be this one, that's 90 degrees. The area of this triangle, well, it's going to be base times height. Base times height divided by 2. So the square root of 3 times 1 divided by 2, or square root of 3 over 2 inches squared. Square root of 3 over 2 inches squared. The perimeter, you add up the 3 sides, well, it's 1 plus 2 plus the square root of 3. These are like terms, so you get 3 plus the square root of 3. 3 plus square root of 3 inches. That's the perimeter. All right, that's one problem. The next one's going to be almost exactly the same thing. Construct triangle XYZ at S equals 6 centimeters, 6 centimeters, 6 centimeters. Okay, so we're going to raise this out to 6 centimeters. And there's one arc, and there's the other arc. The location where they intersect is, of course, the third vertex. So here is our equilateral triangle. Each side is 6 centimeters, so might as well mark that right away. 6 centimeters, and of course all three of these angles have to be 60 degrees because it's an equilateral triangle, so the angles are all congruent. Okay, now construct perpendicular bisector YW bisecting XZ. Alright, so here's XZ, so I need to do a perpendicular bisector this time. So the way I do that is I do an arc from here, and I do an arc from here. And that, of course, allows me to do this. What I have to realize is that this actually has to go to this point here. So this is point Y, and W is going to be this location where that intersects. So it ends up having the same effect. See, the perpendicular bisector here has the same effect as if it was an angle bisector. It does exactly the same thing. In this case, it cuts this in half into 3 centimeters and 3 centimeters. So, how long is XW? XW is right there, 3 centimeters. How long is WY? WY is this one. It's going to be 3 times the square root of 3. Because it's B is A times the square root of 3. 3 square root of 3 cm. How long is XY? 6 centimeters. What's the measure of angle YXW? YXW is 60 degrees. XWY is this one. XWY, that's going to be your 90 degrees. And measure of angle W. yx is going to be 30 degrees. The area, base times height divided by 2. 3 times 3 square root of 3 is 9 square root of 3 over 2 centimeters squared. And last, perimeter. Again, these are the like terms. This is a non-like term. So 3 plus 6 is 9, so it becomes 9 plus 3 square root of 3 centimeters. And that is the perimeter. Okay, so that's it for the two 30, 60, 90s. Let's do some 45, 45, 90s. It says construct segment QS and segment PR intersecting at T. So here's QS and here's PR. And it says they intersect at T, so this point will be called T. Okay, what they do is they bisect these angles, so these all become 45 degrees. And if this is 45 and this is 45 and this is 90, and therefore all of these are 90. So you just got a lot of information for free. Okay, measure of angle TQR is 45 degrees. Measure of angle QTR is 90 degrees. Measure of angle TRQ is 45 degrees. TQ is this distance. Now, if this is 6 centimeters, then this has to be 6 centimeters divided by the square root of 2. So look what you get. You get 6 over the square root of 2. You can't do that, so you've got to rationalize the denominator. So what you get is, temporarily, 6 square root of 2 over 2, and that reduces to 3 square root of 2. Because this times this is 2, and the 6 over the 2 reduces to a 3, so it becomes 3 square root of 2. So this is 3 square root of 2, and this is 3 square root of 2. And this is 3 square root of 2, and this is 3 square root of 2. So you may notice then that this together would be 6 square root of 2. You get 6 square root of 2. So that's pretty interesting. So anyway, TQ is 3 square root of 2. TR is 3 square root of 2. Let's just finish this problem because the next one's just like it. Okay, SQ is this full distance, so like I just said, it's 6 square root of 2. And QR, of course, is 6. Oops, 6. And SR is 6 as well. So you notice we have 6, 6, 6 square root of 2. We have 3 square root of 2, 3 square root of 2, 6. So there seems to be a pattern here. Measure of angle QSR, here's Q, here's S, here's R, it's 45. Measure of angle SQR is also 45. Do you notice a pattern? Well, what I notice is that we have a big 45, 45, 90 and a little 45, 45, 90. And when you cut a 45, 45, 90 triangle in half, you get two more that are exactly the same thing. So every 45, 45, 90 triangle can be made into two more 45, 45, 90 triangles, which is interesting. You can just keep dividing them up. In other words, more, 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 and they keep exactly the same shape. They're always the same, 45, 45, 90. 45, 45, 90. They keep dividing and dividing and dividing, and they'll always have the same ratio. A equals B, C equals A or B times the square root of 2. So once you've got it, you totally got it. Let's call that a day. Good luck on your homework. I hope you get it all done. I hope you understand it. I hope you do great, and I hope to see you in class soon. Bye.